Hey everyone, welcome to TH Academy. Hope you guys are great. So in this video, we are going to learn about indifference curve analysis, which is a very important topic in microeconomics that helps us understand how consumers make choices between two goods. We will explore what an indifference curve is, how to draw it, what it means, and the key properties that make it so interesting. We will also see examples, tables, and diagrams so you can easily understand this topic visually. So let's start learning step by step with the first slide, that is, what is an indifference curve? An indifference curve is simply a graph that shows different combination of two goods that give the same satisfaction to a consumer. In other words, it shows how a person can choose between two products, say chocolates and ice cream, and still remain equally happy. So we can't measure satisfaction in numbers, but we can say which combination makes us feel better. That level of satisfaction is what the indifference curve represents. Imagine a smooth line on a graph where every point gives the same happiness. That's your indifference curve. So basically, indifference curve is something like that. This is indifference curve. Now, understanding what is indifference curve analysis. So indifference curve analysis helps us analyze consumer behavior using a simple two-dimensional graph. We put one good on the x-axis and other on the y-axis. Each point on the curve shows a combination of two goods that gives the same satisfaction to the consumer. The consumer does not prefer one point over another. They are equally in terms of happiness. So this analysis helps economists understand how people make trade-offs when choosing between goods. Now, let's understand what is an indifference map. When we draw more than one indifference curve on the same graph, it's called an indifference map. As you can see on the screen, this diagram here, there are three indifference curves. Indifference curve 1, and okay, we can also say indifference curve as IC. So IC1, IC2, and IC3. There are three indifference curves in the same graph. So this is called indifference map. Each curve represents a different level of satisfaction. A higher indifference curve shows a higher level of satisfaction, while a lower indifference curve shows lower satisfaction level. For example, here IC3 shows higher level of satisfaction than IC2 and IC1. Similarly, IC2 shows higher level of satisfaction than IC1. That's how it works. So when you look at an indifference map, the topmost curve represents the most preferred combination of goods. Think of it like a map of happiness. Higher curves means you are happier and lower curve means you are less happier than. Okay. Now let's look deeper. Suppose we have three curves, IC1, IC2 and IC3. Each one shows a different level of satisfaction. Each point on the curve gives equal satisfaction, but moving to a higher curve, say from IC1 to IC3, means more satisfaction. So in short, higher curve is equals to higher level of satisfaction. Now let's understand what is an indifference schedule. An indifference schedule is like a table that lists different combination of two goods that give the same satisfaction. We use this schedule to plot points on a graph, and when we connect those points, we get the indifference curve. It's a simple way to move from data to a visual diagram. What is indifference set? An indifference set includes all the combination or points on a single indifference curve that give the same level of satisfaction. Every point in this set means the consumer is equally happy. No combination is better or worse. Now, understanding this with the help of example. Sara's indifference curve. Now, let's make this concept practical. Meet Sarah. She loves chocolates and ice cream. She consumes different combination of these two items that make her equally happy. We have a table showing these combinations, and when we plot them on a graph, we will understand or we will get an indifference curve. That is basically Sarah's indifference curve. Here table is given combinations chocolate and ice cream. So combination A includes 1 chocolate and 16 ice cream. Combination B includes 2 chocolates and 8 ice cream. Similarly, combination C, D, and E includes 3, 4, and 5 chocolates, and ice creams are like 4, 2, and 1. So these are basically combinations which we represent from A, B, C, D, and E. So when you plot these points on a graph, we will get a smooth downward curve sloping like that. Okay. So here's the table. Now, when we plot these points A, B, C, D, and E, we get a smooth downward sloping curve that represents Sara's indifference curve. Each point gives her the same level of happiness with different mixes of chocolates and ice cream. Say at point A, look at the diagram. At point A, she consumes 1 chocolate and 16 ice creams. At point B, she consumes 2 chocolates and 8 ice creams. Similarly, at point C, 3 chocolates and 4 ice creams. At point D, 4 chocolates and 2 ice creams. At point E, 5 chocolates and 1 ice cream. Now, let's understand what this figure means. Sorry. As Sara eats more chocolate, she must give up some ice cream to stay equally satisfied. Let's say from A to B, she gives up 8 ice creams. From moving A to B, she gives us 8 ice creams. Like 16 minus of 8 is equals to 8. From B to C, she gives up 4. From C to D, 2. And from D to E, only 1. So, this pattern shows the marginal rate of substitution, MRS. Now, what is marginal rate of substitution? The rate at which Sara gives up one good to get more of the other while staying equally happy. Now, this trade-off between two goods is called MRS. Now, understanding what is marginal rate of substitution with the help of its formula. Here we go. The marginal rate of substitution is the amount of one good a consumer is willing to give up to get one more unit of another good without changing their total satisfaction. In simple terms, it's how much you are ready to sacrifice of one thing to get a bit more of another. Mathematically, MRS is equals to change in good X divided by change in good Y, or delta good X upon delta good Y. It tells us how preferences change as we move along the curve. Now, our next slide is indifference curve property. First one is indifference curve slopes downward from left to right. The indifference curve always slopes downward from left to right. Why? Because when a consumer gets more of one good, they must give up some of the other to keep satisfaction the same. If both increase together, satisfaction would rise, not stay equal. So one good increases while the other decreases. That's why the curve slopes downward. Second property is indifference curve is convex to the origin. The curve is convex, it bends inward because of the diminishing marginal rate of substitution. Means as the consumer gets more of one good, they are willing to give up less of the other to get one more unit. For example, to move from 1 unit to 2 units of good X, the consumer gives up 3 units of good Y. Look at the diagram. From moving from 1 unit to 2 unit of good X. Look at this. 1 unit to 2 unit of good X. The consumer like gives up 3 units of good buy from 10 to 7. This shows the willingness to sacrifice the other goods keeps decreasing, which makes the curve bend inward smoothly. Now, next property is higher indifference curve represents the higher satisfaction as we discussed before. Like a higher indifference curve means a higher level of satisfaction. For example, at point A on IC1, look at the diagram. At point A on IC1, the consumer gets fewer goods. At point B on IC2, the consumer gets more of both goods, good Y and good X. So, since having more goods gives more satisfaction, so IC2 represents a higher satisfaction level than IC1. So, the higher curve, the happier the consumer. Next property is two indifference curves never intersect. Two indifference curves can never intersect or cross each other. Each curve shows a different level of satisfaction. If they intersected, one point would represent two satisfaction levels at once, which is impossible. So remember, curves never cross. Indifference curve never touch the axis, x-axis or y-axis. Why? Because the concept assumes that the consumer wants both goods in some combination. If the curve touched an axis, it would mean they are consuming only one good and none of the other, which goes against the idea of consumer choice. So curves always stay away from the axis. Now let's quickly revise everything we learned. Indifference curve shows equal satisfaction from two goods. Indifference map means multiple curves showing different satisfaction level on the same graph. MRS, which is the marginal rate of substitution, the rate of giving up one good for another. Properties. Number 1 is curves slope downward, are convex, never intersect, and never touch the axis. Understanding this helps us see how consumer makes smart choices between goods to stay equally happy. So thank you so much for watching this video. I hope it helped you understand this topic in a simple and clear way. If you enjoyed this video or learned something new today, please give it a thumbs up. It really helps this channel grow and reach more students like you around the world. Also, don't forget to subscribe to TH Academy and press the bell icon. Your one click truly means a lot to me. It keeps me motivated to create more helpful and easy to understand educational videos for you. And of course, I would love to hear from you. Drop your thoughts or topic suggestions in the comments below. Your feedback always inspires me to do better. Thank you once again for being a part of the TH Academy family. See you in the next video. Take care. Allah Hafiz.